number one, okay, they give you an expression, they give you a formula with three different variables, C, M, and N. And the question is, which change is going to increase the value of the expression the most? So if you put whatever C is, if you increase it by 10, whatever M is, if you increase it by 10, or whatever N is, if you were to increase it by 10. And the C is just all alone. The M, if you increase it by 10, all you do after that is add 5 to it. The N, if you increase it by 10, you add 1 to it, but then you raise it to the fourth power. And exponents are going to make things grow very fast. So N, if you change 10 by 10, or if you change N by 10, that's going to change it the most, because then you're going to raise it to the fourth power. So you're going to times it by itself 4 times. Okay, skip 2, don't worry about 2. 3, what is the factored form of x squared plus y squared? So you can go through A, B, C, D. For example, if I were to expand A, x plus y, squared, so that's x plus y times x plus y. And if you were to work that out, you get x squared plus xy, and then times this y to this x, plus another xy, this y times this y. So you would get x squared, combine your like terms, that's 2xy, and then this last term. So it's not going to be a. Okay, number 4. How many solutions to this equation are imaginary? Okay, they're street smarts way. The best trick to do this, if we take and graph it in the calculator. So x cubed minus 1 equals 0. These are like the roots. These are the solutions where it equals 0. So on my calculator, if I type in y equals x cubed minus 1. So I'm going to go into my calculator, open the graph, and just type in this, because this f1 of x, that's the same thing as y. So after the equals, just punch in x cubed minus 1. X cubed minus, let's see. Okay, then if you hit enter, and you got to look at the graph comes something like this. Comes up, and then comes over, and then comes up right there. Okay, now, because it is a cubic, because the exponent is 3, there are going to be 3 solutions. And here are your options. You can have 3 real, they can all be real, or you can have 1 real and 2 imaginaries. So it's got to be one of these, because you got to remember your imaginaries come in pairs of 2. You cannot have 2 real and 1 imaginary. That's impossible, because your imaginary solutions come in pairs, come in conjugate pairs. So it's either got to be they're all 3 real, or one of them's real and 2 are imaginaries. And if you look at the graph, that is where it equals 0. So one of your solutions is like it crosses right on the x-axis at 1. So if I put 1 in there for x, 1 cubed, 1 times 1 times 1 is 1, and 1 minus 1 is 0, so 1 works. 1 gives you a 0. But the other 2 have to be imaginary, so it's got to be this. 1 real and 2 imaginaries, because your real solutions are wherever it crosses on this x-axis. So how many solutions are imaginary? It's got to be C. Now if your graph looked like this, if your graph came up and then down and then up, then it would have three real solutions, because one solution would be there, one solution would be there, and one solution would be there. So your real solutions are wherever it crosses the x-axis. So the easiest way to do it is just punch in the calculator and look at the graph. Okay, number 4 or 5, you're given a formula to calculate the volume of a sphere. They just want you to rearrange it, manipulate it, solve for r. So if we solve for r, so the volume is equal to 4/3 times pi times the radius cubed. So let's undo this 4/3. So I'm going to divide by 4/3. And if you divide by a fraction, that's the same as multiplying by the reciprocal. So if I multiply by the reciprocal, I'm going to have v times 3/4 equals pi times r cubed. Okay, now I'm going to ditch this pi. I'm going to divide by pi. I'm going to divide by pi. So 3/4 times v. If I make v a fraction, put v over 1. That's the same as 3v on top and 4 on bottom. And so this is what I want to look at. That's going to be the exact same thing. 3v over 4. And if I divide by pi, I'm going to take this pi and move it to the bottom with this 4. So I'm going to have 3v over 4 pi is equal to r cubed. Alright, so now I gotta erase some stuff. If I want to solve for r, now all I've got to do is undo the cube. So I'm going to do the cube root of this side, and I'm going to do the cube root of this side. So this cube root kills this cube, so I just got r equals the cube root of that whole thing, which the 3 is on top, the v is on top, the 4 is on bottom, and the pi is on bottom, and that matches up with a. Because this v is the same as a v over 1, so the v is on top, and just 4 pi on the bottom. 6 is a good one. Factor this expression. Okay, this is x to the 8th minus y to the 8th. Okay, this is going to be a difference of squares. So if it was an easy one, it would be like x squared minus 9. Okay, this one is pretty easy because these are both perfect squares. So x squared minus 9 would factor to be x minus 3 times x plus 3. So one's going to be a minus, one's going to be a plus. And if I distribute it forward, that's going to be x squared plus 3x minus 3x minus 9. So it's going to be x squared. These cancel out. Minus 9. Okay, now this makes me wonder if... Seems like I got distracted by someone. Did we ever even go finish? I never even finished number 3. Okay, so let me go back. Let's go with this guy, and then we'll go back to 3. So x to the 8th minus y to the 8th is going to be a difference of squares. So if I were to write it as a difference of squares, it would be... I think we can do this. X to the 4th squared minus y to the 4th squared. Okay, now these are in terms of squares, and they're both perfect squares. So here we go. We're going to go x to the 4th minus y to the 4th, and we're going to times that by x to the 4th plus y to the 4th. Okay, now let's double check our work. Because if I times through, that's going to be x to the 8th minus x to the 4th, y to the 4th. Or I guess that's a plus. When I times it by that, it's going to be a plus. And if I times this is going to be a minus x to the fourth, y to the fourth. And this is going to be a minus y to the eighth. Okay, that works. But that's not any of my answers. And that is because this first group right here can be, you can factor that one again. So I can break this one down to x squared minus y squared times x squared plus y squared. So this red one is going to factor down into these two groups. And then let's just put this one there, x to the fourth plus y to the fourth. And then this guy right here is another difference of squares. So we're going to go from a difference of squares to a difference of squares to a difference of squares. This one, you can rewrite that as x plus y times x minus y. And then this sum of squares, you can't factor a sum of squares without imaginaries. So x to the fourth plus y to the fourth. And that's going to match up with C. So 6 matches up with C. So now let's go back and look at 3. And I'll show you why you can't factor the sum of squares without imaginaries. So number 3, we eliminated a because a gives us the middle term, and we don't want that middle term. So look at b, that's an imaginary, and d is an imaginary. If you distribute c through, you're going to get x squared minus xy plus xy, but then you're going to get the y's are going to be minus y squared. So these middle terms zero out, but you got x squared minus y squared, and we want x squared plus y squared. So we're going to kill a, we're going to kill c. Now b and d both have imaginary parts, and we're going to go, I think we're going to go with d. Let's look at d. Let's work d through. X times x is going to give you x squared. X times a minus imaginary y is going to be a minus imaginary xy. And the imaginary y times x is going to be plus imaginary xy. And then the imaginary y times a minus imaginary y is going to be a minus y squared. But then the imaginary times an imaginary is going to be I squared, but I squared is a negative 1. So negative y squared times a negative 1 is going to turn that to a positive y squared. And these middle terms are going to zero out. So you're going to have x squared plus y squared, which is what you want. The only way to factor a sum of squares is by imaginaries. So you could just work all 4 of those out and see which one matches up. Alright, let's look at 7. Okay, so interest. If we're going to deposit money, earn some interest on it, leave it in for a number of years, the model we want to see. So A is going to be the amount of money that we deposit. So if I deposit $100 and I earn interest, well, $100, and my interest rate is 5% every year, and if I leave it in for time, if I leave it in for 10 years, then every year 5% of $100 is just $5. So I need to do the $100. That's going to be my amount, and I'm going to times it by, if I just times it by 5%, so 0.05 for 10 years, so 5% at 10 years, this is not going to give me the total amount. I want to times it by 100. I want to times it by 105% for 10 years. Because then this adds the money onto my $100. So if I just times it by if I leave it in for 1 year, so if I times 100 times 5% for 1 year, that is only going to be, the answer to this is $5. So this formula right here will give me how much interest I made. So 5% of $100 is $5, but then I need to take that $5 and add it to what I invested. So in the bank I'm going to have $105. So if you just times it by the interest, that's going to tell you how much interest you make. But if you times it by 1 plus 0.05, this, if you do this on your calculator, if we just do it for 1 year instead of 10, then this will give you, it does this step for you. It adds the 100 to your interest, and this gives you 105. So if you times it by 100% of the money plus the interest you earned, it adds that interest to your principal amount. So we're going to go with C. Okay, 8. B and C, I think they might ask you. I doubt they're going to ask you to do A. So let's look at B and C first. Where is this function positive? This function is positive when let's look. Okay, positive is anything that's going to be, here's my neutral line. Y is 0. So on my y-axis right here, anything going up this way is positive. Anything below this is negative. So this is negative, this part of it, and this part of it's negative right here. So the positive parts of the function are going to be when it's above 0. So that's all going to be positive, and that's going to be positive. So the positive parts are red, the negative parts are blue. So the positive parts, x looks like it's between 0 and 3. So when x is bigger than 0, anywhere this way, or less than 3, it's positive. And then anytime x is greater than 5, it's positive. Okay, the negative ones, when x is, I think this is going to be this region here. When x is smaller than 5 but bigger than 3, it's going to be negative. And then this guy, anytime x is less than 0, it's going to be negative. Okay, now to come up with the model, I don't think they're definitely going to have you do this, but let's look at these 3 roots. This one, since it changes directions twice, I know it's going to be a cubic. This is some kind of a cubic, some kind of x cubed. And we actually have 3 real roots. So the roots, you can use roots. The roots are x is 0, x is 3, and x is 5. Is that right? 0, 3, and 5. I gotta erase this stuff. 0, 3, and 5. So if your roots are 0, 3, and 5, remember we could do this. X minus 0 times x minus 3 times x minus 5. That will always give you 0. Because if you plug in that root, 3 for x, 3 minus 3 is 0. So the roots are kind of opposite what the equation is going to be. So now if we just distribute this, I'm going to distribute these first. This is going to give me x squared minus 8x plus 15. Then if I times that by x minus 0 is just the same as times it by x. So if I distribute that through, that's going to be x cubed minus 8x squared plus 15x. So that is going to be it, except for your cubic is kind of just like a quadratic. It's going to be ax cubed plus bx squared plus cx plus d. So we've got everything. There's not a d. The c is 15. The b is -8. We just don't know a. A is kind of like your dilation. So to find a, you've got to pick a dot to find kind of the slope, the steepness of this. Because I could have a totally different parabola or a cubic that goes through these three dots. I could have something that goes like this. I could use those same three dots but get a totally different picture. So A is going to be unique to this cubic. So if I can find a dot, and that's going to be maybe too hard to do unless I zoom in, I've got to find just an X and a Y that I can plug in. And maybe there looks like there's one there, but I'm not sure. So your X, Y, that one is going to be 2 and 6. So if you plug, we're trying to figure out what A is. If I plug the 2 in for the X, so I gotta drop it in right there, I gotta drop it in right there, and I gotta drop it in right there. And then I gotta plug the 6 in for the Y. So it's gonna be 6 equals A times 2 times 2 times 2 is 8 plus 2 times 2 is 4. 4 times -8 is a -32. And 2 times 15 is 30, so that's a plus 30. So add these like terms. A 30 and a 32 is going to be 6 equals 8. A, what is that? Minus 2. So plus 2 plus 2. So 8 equals 8a, divide by 8, divide by 8. So A happens to be 1. So then your answer is, oh, they're not even, they're telling us, I guess it's 1. Oh, so maybe that is a decent question. So they're telling you that A is 1, so we didn't even need to find A. All we needed to do was find this B. So in front of the x cubed, that's going to be a -8. And then that's a plus. Or I guess you could do a minus and then 8 plus a -8. You're going to have to do minus 8 because we don't have any -8s here. So you'd have to do minus 8. That's minus, that's 8x squared, and then a plus, and then a 15x. So that's kind of a nasty problem. Okay, let's skip 9. That's kind of a geometric series. We haven't really got to those yet. 10, let's look at 10. How many solutions does this have? So this, because it is a degree 4 polynomial, it's going to have 4 solutions. So here's your options. Could be all 4 are real. You could have 2 real, and you could have 2 imaginary. Or you could have all 4 imaginary, because your imaginary's got to come in pairs of 2. So you could type that in on a graph and see what it looks like. If it were to cross 4 times, 1, 2, 3, 4, then you'd have 4 real solutions. But if it were to cross only twice, so like 1, twice, then it would only have 2 real and 2 imaginary. Okay, 11. Find the zeros of the polynomial. And this is cubic, so there's going to be 3 zeros. So if we can use the Street Smarts. We can type this in the calculator. So let me do that real quick. I'm going to type this in the calculator and look at the graph. Alright, so we're in business because it's going to cross 3 times. So your graph is going to look something like this. It's going to go like this, come up, and then come down here and go back up. So you're going to have 3 real zeros. Okay, so now if you go into the wrench, if you hit the wrench and under your tools, if you hit analyze graph, so hit the wrench, hit analyze graph, and then hit 0. You can calculate the zeros. The calculator will do it for you. So if I hit 0, and then I just set up the boundary lines of where. So one of the zeros is a negative 1.73. That's this guy right here. Okay. Now I'm going to do it again. 0. This guy is a positive 1.73. And then the last 0 is pretty close to that 1.73. Oh, I can't even read it. Oh, it looks like it happens right on 2. So these are your 3 zeros. That's where it's going to cross. Alright, 12. After party, there are 2.5 cakes left over. Brandon eats half of the remaining cake every evening. How much of the cake has he eaten after 7 days? So 7 days, we're going to cut it in half, cut it in half, cut it in half, cut it in half, cut it in half 7 times. So it's going to look like this, 1/2 to the 7th. How you doing, baby? So 1/2 to the 7th. And it looks like they all use that. So it could be A, B, C, or D. So far we haven't eliminated anything. Now if I do 1/2, if I do that for 3 days, that's going to be 1/2 times 1/2 times 1/2, that's going to be 1/8. So if I want to know 1/8 of some amount, 1/8 of 4, say I had 4 cakes left. 1/8 of 4 cakes would be times them. So it's times 4/8. That's going to be, you're going to have half amount left. So Tanner, what are your feelings on this?
I'm going to rock it. I don't know.
That's the spirit. So we got to have this. It's going to be D. You're going to choose D. D, because you're going to take 1/2 7 times and you're going to times it by how much was there. 2.5. 2 and 1/2 cakes really is the same thing as 2 times 2 is 4 plus 1. That's 5 halves. So if I times that by how much was left, if I times that by 5 halves, that is going to be how much he's eaten over the 7 days. So 5 halves times 1/2 to the 7th. But now if I subtract that from the total that was there, I need to subtract that from the total, and that's how much was in his belly. So if I take the total amount was left, 5 halves, and I minus this much, that's how much he ate. Okay, 13. If you expand this, then so 2x plus y to the 4th is the same thing as 2x plus y times 2x plus y times 2x plus y times 2x plus y. So if I distribute, I'm going to get 4x squared plus 2xy plus 2xy plus y squared. So I'm going to get 4x squared plus 4xy plus y squared. And since that's what I get from those two, I know that's what I'm going to get from these two. So it's going to be 4x squared plus 4xy plus y squared. So now I just need to fill in these three blanks. So if I do 4 times 4, that's going to be 16x to the fourth. And then what else do I need here? How many x cubes? So 4x squared times 4x, that's going to be 16x cubed y. But then I've got to add, where's the other one going to come from? It's going to come from this guy times this guy. That's going to be another 16x cubed y. So that's going to be 32 of these x cubed y's. So it's going to be 1632.
I don't think that's right.
Hunter Palmer has error spotted. An error spotted. Okay, now we just got to figure out how many of these xy cubes. So where are these xy cubes going to come from? The xy cubes are going to come from these guys. So when I times this y squared to this, that's going to give me 4xy cubes. And when I times this y squared to this guy, that's going to give me another 4xy cubes. So my xy cubes, I'm going to have 4 and 4. I'm going to have 8 of them. Okay, long division. So if we write in long division, it's going to be 2x cubed minus 3x squared minus 3x plus 6. And then over here you put the x minus 3. And then you can figure out the long division or do even some synthetic division. But the remainder can be found by evaluating f of, this is where we're going to look right here. We're going to take 3. If it was x plus 3, we would plug in a minus 3. Because there needs to kind of be a minus in the thing. And x plus 3 is really like x minus a minus 3. So take the number, plug it in here, f of 3. That means this. If you take a 3 and you substitute everywhere there is an x, so 3 cubed, 3 times 3 times 3 is 27. 27 times 2 is 54. 3 squared is 9. 9 times a negative 3 is a minus 27. 3 times 3 is a 9, so minus 9 plus 6. This will give you the remainder. So 54 minus 27 minus 9 plus 6. So the remainder is going to be 24. Or you can divide it out the long way and verify that you get a remainder of 24. But the trick of just calculating the remainder is just plug whatever this number is in to the function, but don't take that minus as part of the model. It's not part of the number, and that will give you the remainder. Okay, 15, a perfect square. Which one can be rewritten as a perfect square? So a perfect square is like x minus 2 times x minus 2, or x plus 2 times x plus 2. So the ones we did before was kind of a difference of squares. We had x minus 2 times x plus a 2. Let's have a shout out, Holly Fleming. Holly has glass in her eye. Everyone, keep Holly in your thoughts. So we're gonna go with A. A is the answer. If you write this as if you factor this, it's gonna factor to a cubed plus 2b. And if I times that by a cubed plus 2b, now when I distribute, a cubed, that's going to be a to the 6th. A cubed times 2b is going to be 2a cubed b. 2b times a cubed is going to be another 2a cubed b. Then 2b times 2b, that's going to be 4b squared. And then your two middle terms are going to combine and give you 4a cubed b. So 15 is the one that you can factor into a perfect square. 16. Okay, in an experiment, the population of a culture doubles every hour. There's 30 at the start. Which expression represents the total dish after 3 hours? So doubling, that means you're going to times by 2, times by 2, times by 2, times by 2. So if it doubles every hour, it's going to be 2 cubed. Or 2, I guess t hours, 2 to the t, whatever t is. So how many ever times you double it, that's what's going to be t. So if it were to double 4 times, 2 times 2 times 2 times 8, 2. That's is that 16? 2 times 2 is 4 times 2 is 8 times 2 is 16. And then you would times that 16 by what you started with. So this is what you start with. We're going to go with C. And then we're going to double it, so we're going to times it by 2. And then this t represents how many times you're going to double it. Okay, 17. If you multiply and use this geometric model, so x minus 2 times x plus 5, if you distribute, that's going to be x squared plus 5x minus 2x minus 10. So it's going to be x squared plus 3x minus 10. So now this x times x, that's going to be x squared. X times 5, that's going to be 5x. A negative 2 times x is a negative 2x. And a negative 2 times 5 is a negative 10. And if you add up, I guess these are your like pieces. So you're going to get the same answer. X squared plus 3x minus 10. Okay, this is similar to like number 3 that we did. So x squared plus 9. And because it's a plus, it's got to be imaginary. It's going to be c. If I distribute, that's going to give me x squared. X times a negative 3i is going to be a negative 3ix. 3i times x is a plus 3ix, and those zero out. But a 3i times a negative 3i is a negative 9, and I times I is a negative 1. So negative 9 times negative 1, x squared plus 9. Okay, that's it.